Okay.
July 7th.
Just started recording. It's July 7th SIG scale meeting. Back to you, Joe.
Yeah, and we will be posting these video public, so don't say anything that you wouldn't want to show up on the front page of the newspaper. That's a pretty high standard. All right, so let's start out agenda items. Is there anything that folks want to bring up and talk about? Now, I know, Bob, there was some talk of Samsung showing off sharing scale data. Are you guys ready to demo that?
Yes, in a limited form. So basically what I wanted to show is two ways that we can save Prometheus data. And it's not a complete demo at this point. I'd like to actually give this at a meetup or something else where I actually have slides. But I wanted to kind of show everybody the two options we're thinking about and then get some feedback in terms of what other people are doing and what they think.
Okay, that sounds great. So I'm going to demo in ways to save and share Prometheus data, right?
The floor is yours, I think.
What'd you say, Bob?
Oh, I said the floor. I think the floor is David's, isn't it?
Yeah, I just want to make sure that there's other stuff that people really want to get to today that we can get to it. But going once, going twice. All right, David, please take it away.
Okay, let me see how to share my screen.
I have a green button on the bottom bar that says green icon share screen. There you go.
Okay. Okay. So the motivation for this is we run a lot of tests and we run a lot of benchmarks, but we don't retain a lot of that data and we don't share it in particular. So there are some tickets going back as long ago as 1 year with Prometheus talking about how they intend to do long-term storage. It's issue number 11 for them. And they have said that they do not intend to take responsibility for long-term storage. So some of the reasons that we want to find a way to share this data are that we know that Google, CoreOS, Red Hat, et al. Have been collecting a lot of data, as well as ourselves, and we think that there's value in being able to share that data so that we can compare different implementations and different stacks. So given that Prometheus doesn't have a way to do this now, we've looked at two possible ways to do it. So I'm going to show you the first way. So I'm doing this locally. This is not going to be on a Kubernetes machine, but the commands are analogous. So they're just some basic Docker commands. So to start out, I have a default Docker machine. And this is odd, I can't quite see. How do I hide myself? There we go. Okay, so so this is the Docker machine that I've set up on my local system. And you can see that I'm not running any containers. So to start out, I'm just going to start Prometheus. And once I start it, let me explain what each thing here does. So first of all, I have a basic Prometheus configuration. And I'm just scraping myself. So nothing fancy. The other things to note are that I've set the storage directory to be from the root partition Prometheus. And then I've set the local retention time. So this is really important because Prometheus, because they do not intend to be a long-term storage facility, they periodically will cull data. The default is approximately 2 weeks or 15 days. So clearly, if we back up Prometheus data and then we want to view it a month from now or a year from now, which is not unreasonable, as soon as you start Prometheus, it will cull all of the old data. So we purposely start Prometheus with a long retention time, and in this case, I've chosen 100 years. So
Is there any talk in the Prometheus community about sort of having Prometheus run in sort of a view-only mode versus sort of a collect and, because I mean that's kind of what you want to do, is you want to be able to point it at some data and have it be read-only on that data.
So I haven't seen anything talking about read-only. You can set, and then in the case that we're going to show here, what we do is we actually we change the configuration so that we don't collect any more data once we start viewing it.
I'll be quiet and watch the demo.
It's not that interesting. It's a good question. So please ask questions as soon as anyone has any. So we can see I have this container now. Let's see if I can see anything. So here are the metrics that I'm collecting for the purposes of this demo. And so the next thing to do is we've been running for, we've been running for 2 minutes. And so what we want to do is we want to go ahead and collect this data. Now, I'm skipping one small step, which doesn't technically matter. But what this means is, so what I'm going to do now is I'm going to back up all of the data. And so what I've done is I've executed a tar command inside of the Docker container. And I've just tarred up everything in the database directory into a backup directory. Now you can see from the way I mounted this, the backup directory is actually another directory on my host machine, right? So now if we look in backup, we can see here's this tar file that I've created that contains my Prometheus data.
Is there anything you can do to cause Prometheus to flush that to disk, or is it, you know, is it caching stuff? I mean,
so that's the purpose of this local memory chunks parameter here.
oh, okay.
By setting it lower, you can cause it to flush data to disk more quickly, but there's currently no synchronous way to ensure that all of the data is on disk. So in the real world, what you would normally do is, you know, pause for 5 seconds, just like in the old days with ext3, just to wait for the 5-second sync, right? And this is one of the limitations of this method of collecting. And we'll see later a different method of collecting which doesn't have that limitation, but then has other limitations. So we've backed up this data, and let's go ahead and get rid of our restore directory. So we're going to make our restore directory, and this part I'm hoping does not fail for me. So okay. Okay, so I've copied that data into the restore directory. And I'm going to go ahead and get rid of the previous container.
What's the format of that data? Is that something that's documented somewhere? Are there other tools for manipulating it?
So no. So this is the interesting thing, is that all of the storage, the back-end storage formats are all, well, they're not proprietary. Many of them, most of them are open source. However, there aren't many tools that know how to natively manipulate that database. And in particular, you wouldn't want to, because if you had Prometheus modifying that database, which would be the normal case, you would end up with corruption. Right. You had two people potentially reading and writing. I just wanted to point out that there is a really good article here that talks about the way that storage is saved and what indexing, and then they use their own proprietary format, which is documented here, in order to store the data on disk. What they do is they have one file per time series. And so for very large clusters, you need to shard and have multiple Prometheus servers. And in fact, if you have a very large number of time series, you have to worry about running out of file descriptors. So those are two known scalability problems with Prometheus, which can be fixed by sharding. So we don't have a great way of accessing this data except through Prometheus. Now, so we've got this data here, I think. This actually might not work. This doesn't look like a valid file or directory. So you can see here, I'm trying to mount this with Prometheus static at this point. And the reason is I want to stop scraping. So for this read-only view, it's a read-only view in the sense that I've configured Prometheus not to scrape anymore. So it won't add data, but it still will cull any old data, except for the fact that I've set the retention period to be 100 years. Yeah. I have a feeling one of my paths is going to be wrong, so I just wanted to do this slowly. So all of these parameters are essentially the same thing that we saw before.
So it looks like, I'm just reading through the Prometheus docs, it looks like there's a checkpoint interval on the local storage system that defaults to 5 minutes. So right. Maybe that it didn't checkpoint and flush stuff.
Right.
Yeah, so we're using it in a weird way.
What we did instead is we'll just go ahead and choose a different tar file. And this one we'll just choose from yesterday.
The Julia child, take one out of the oven.
Okay. So let's look at that restore directory. So that is a restore directory. And the problem then is just the path, I think. No. Okay, sorry about this. So let me just verify everything is where I think it is. That's there. Oh. So let's do this. Okay, so now we have a Prometheus instance again. Again, I apologize. I've been modifying this since 5 this morning. So just a few hiccups. So we have Prometheus server running again. The Docker machine IP has not changed, so let's go ahead and see if we can access it. I reloaded the metrics page, and sure enough, there is data there. So let's go ahead and let's do a query. So I did a query now, and it says there is no data. And the reason is because my time. So the way the range queries work is you specify a Unix timestamp for the beginning and the end, and then you specify a step in seconds. And there is no data for the time period that I've chosen because the time period I chose was in the morning, and we're no longer in the morning. And so I go back in time and I try to do this, and I run into a problem, and that's that you can only ever query 11,000 points per time series. Let's see, how can we find out? Well, so let me finish off with what I've demonstrated so far. I've backed up Prometheus. I've restarted it using a database from yesterday, and I now have the difficulty that I can't actually easily query it because I don't remember what the date was in a Unix timestamp yesterday. Let me see if I have anything in my notes. Maybe this.
You had a second method you wanted to run past folks too? Was that the?
Yes. Well, so we're pretty much at the second method. So let me just summarize the difficulty with the current method. So the advantage of the current method is everything is in Prometheus. It's compact, which I do not think is a particular advantage. Because the reason that's not an advantage is that when you actually do analysis with this data, you're going to be dealing with large data sets, and in all likelihood, you're going to end up using MapReduce jobs or some other tool. I mean, you could depend on Grafana if all you want to show is a dashboard, but I think part of the value of sharing is to be able to do sort of the comparative analysis that we saw with the CoreOS scalability paper. One of the things you'll notice about the scalability paper they did there is that none of their graphs were dashboards. Their graphs were all generated using something like Matplotlib, Boca, or even it could have been R, but it's used. They used graphing libraries that are amenable for print and publication. So the current method that I've shown is that you can stand up a Prometheus server, point it at an old database, it will start, and you will have that data. And then you can point your Grafana front end to it, and you can have all of your pretty dashboards and do whatever you want with it. However, not everyone may run Prometheus. So there's a second way that we could collect data, which doesn't have some of the limitations of the previous one. So the previous one, we saved the raw database itself, which is, again, it's Prometheus specific. There aren't many tools, if any, that I'm aware of that are able to read it. But using the, once we have a Prometheus server up, we can query it, and that's the reason you need the timestamp. Probably, here's a better thing to do, actually. So I'm just going to go ahead and stop this Prometheus server. Get rid of it. And I'm going to go ahead and start a new Prometheus server so that I know what time it is. Okay. So now we have a Prometheus server again. We reload, we see that we have metrics being collected. And so now we're just going to go ahead and query it. Now this query is going to fail because the times will be wrong, but we're going to fix the times because we know them now. So this second method the second method is essentially the same. Just going to see what I've done wrong here. Am I too far into the future? Well, I'm not sure. At any rate, what you saw earlier, and I'm not able to show right now, is you can query the Prometheus database while it's running. So instead of actually capturing the database, you can query it and get a JSON result. So an alternative way of sharing data would be to just save the JSON. And what you would do is for each of the metrics on this metrics page, or any of the ones that you wanted to share, you would do a query which covers the duration of the test, and you would just curl that query into a file, and then share those flat text files with others. Now, one of the advantages of doing this is that you then have the data in a format that you can import into any of the tools I mentioned earlier, things like R, Bokeh, Matplotlib, etc. And so you can do more advanced analysis that you can't do using simply Grafana. The disadvantage of this is you lose Grafana's querying capabilities because you only have the ability to use the query language at the time that you capture the results for sharing. So those are the two ways that we have right now for sharing Prometheus data. I guess the question I have for the group is, what do we think is the value proposition in between itself and then sharing that, which then has the complexity of people having to start Prometheus to see the data. But you get the advantage of having the query language versus storing just simple JSON for sharing, which gives you the advantage of more tools can understand JSON, but it's a lot, well, the size, again, already doesn't matter. You lose the ability to use the Prometheus query language, which I think is a pretty significant loss. Does anyone have any opinions?
I mean, so the ideal here would be something that mixes these, where we have something that is usable by both Prometheus itself so that we can sort of retain the querying language, but then is also, you know, well documented with good tool sets so that it can be used in other contexts. Would you say that's correct?
I agree.
I mean, like that would be the sort of, you know, if we could wish for a pony type of thing.
Well, it's actually easy, right? We would just do both. We would save the database and then we would save the JSON. Right.
Okay. Yeah. I mean, at the end of the day, it's probably for a scale run, it's going to be a lot of data, but not an outrageous amount of data, right? Right.
Yeah. So I think that the amount of JSON we're talking about saving is on the order of, you know, tens of megabytes, which is even if we were talking about hundreds of megabytes, I wouldn't think that's too much. Storage is relatively cheap. And again, one of the reasons that I think that actually storing the JSON is better is that I think that at some point we'd like to be able to do more than simply create dashboards. I think that in order to do more fine-grained analysis, we're going to want to do things like CoreOS did, where we actually instrument Kubernetes to emit additional events to Prometheus, store them, and then we may want to compare those in different ways. That I don't think Grafana will allow you to do easily.
So I may have missed this during your walkthrough, David, but did the second method allow for easier normalization of timestamps? It certainly felt like you were having to fumble between today and yesterday and tomorrow for timestamp queries. And back in the I Want a Pony world, I'd love to see a time series that was like normalized to, you know, 0 is the first timestamp onwards. That way, conceivably, we could at least visually compare different test runs pretty easily if they started from the same checkpoint or something.
Right. So that's a good point. I'm not aware of a way. So I know that Prometheus does store the timestamp, and the timestamp that it stores is now. So it doesn't ever start at 0. You can have it seek to a certain time and consider that 0 for the purposes of graphing. But the data itself, as far as I'm aware, is always stored as the current timestamp, as the node sees it. That's something that if you were using like a Python program or something to read the JSON, you could account for that and modify it fairly easily. And I think Grafana, you could also seek to a particular time. But you're right, you would need to know the time. I think that part of the difficulty with this presentation is that because I'm not showing Grafana, I did have to have a little bit more knowledge of the timestamp. And so that's something that if you look at the, and I know this doesn't fix it, so your point's well taken, and I think it is something to consider. But if you look at my original backups, I wasn't including the timestamp. And I only started including the timestamp this morning because I realized I couldn't do the math in my head fast enough.
Okay, well, I just wasn't sure if this is something like another tool like Grafana could fix for us, but in an end-to-end solution, that seems like something we would need. And but there was certainly a lot of chatter in the Prometheus back channel. They continue to maintain a hard line that Prometheus is not meant for long-term storage, it's not meant for archival, and it's not meant for backfilling. So their proposal for things of this nature is you need to have Prometheus dump off to external databases as quickly as possible, something like InfluxDB or something like OpenTSDB. And it could be that that's sort of the longer-term version of option number 2. I think maybe the hope here was that option number 1, if we could just fake Prometheus out with the right amount of data, was going to be lowest cost, best effort, get us 80% of the way there. But seems like we need a little more polish at the moment.
So I specifically actually didn't, so you're right that, as I mentioned, they do not, Prometheus is not going to be a long-term storage platform ever.
Right, it was definitely, just to be clear, it was super Prometheus just over and over and over again. That was, many months ago, so things may have changed. But certainly for the collection aspect, I think Prometheus dumping into its own files as quickly as possible seems like that still scales well. But the export story seems a little painful.
So I purposely didn't bring this up because I think it's a more contentious and potentially long-running discussion that we'd have. There is talk of using InfluxDB as a long-term storage solution for Prometheus. There's also talk of potentially using some other database. My vote personally leans towards InfluxDB, but I think that there are potential problems with the fact that the clustered nature of InfluxDB has become closed source as of a few months ago, et cetera, et cetera. So I completely agree with you that having a different long-term storage format is something that we need to follow up on. But the purposes here is really just to find the lowest common denominator that allows us to move forward now without having to resolve the issues of whether or not we want to use InfluxDB or something else. I intend to continue looking into InfluxDB, but I think that the JSON representation is clearly the lowest common denominator. So, yeah.
Did you try running Prometheus with InfluxDB as a backend on, let's say, 200 nodes? Because from what I know, there was some performance problem with older version of InfluxDB. I don't know if it's fixed in the newer
that's exactly
version.
what I was alluding to earlier. So back in September or so, Samsung SDS was doing Prometheus collection on 1,000 nodes, and we found exactly what you did. That InfluxDB just doesn't scale for write at that volume. InfluxDB 0.8 or InfluxDB 0.9, take your pick. How they handled the wide variety of columns that Heapster or Prometheus threw at it just fell apart. So the reason I think we're talking about InfluxDB here isn't to write data into it as quickly as possible, but use Prometheus for that initial collection of data from your cluster, have it write to whatever Prometheus's custom flat files are, and then use some other process to bulk export that over to InfluxDB. It could potentially be that import and export with InfluxDB is a better story than Prometheus's story. But I agree with you that writing directly into InfluxDB from Prometheus at runtime or at test or data collection time is probably not a scalable thing. I am basing this on many months, so things may have gotten better, but I'm also
yeah. I think that we would only, my interest would largely be to use InfluxDB as a format for sharing. I think that the scalability problems that people see with InfluxDB, many of them are due to the fact that InfluxDB has a format which takes an order of magnitude more space than Prometheus. It's not nearly as compact. And the reason is because they denormalize everything so that every data point has all of its metadata with it. Some see this as a disadvantage because they think that they want to save space. In my experience, and I had this at Amazon, we spent a lot of time trying to compress all of our metrics, and what we found is it was effectively like encrypting our metrics because we couldn't get any of our tools to work with the compressed versions. So we ended up deciding that we would take the 3 or 4 orders of magnitude storage increase in order to be able to have easy access to the data, because storage was cheap, but programmer time was not. So I think that Prometheus, historically, there has been complaints about its scalability. I think many of them are probably due to the fact that it requires more hardware to do the same thing Prometheus does because it's doing something, it's making a trade-off. So that's something we could revisit later. But to your point, Aaron, I think there is, when you're talking about archiving, I don't think you have any scalability problems because you're not, again, it's not real-time ingestion. It's just a background batch process.
Right. I think related to the InfluxDB comment and our earlier experiments, it started to become obvious that the InfluxDB cluster required that you would need to scale up in order to measure a cluster was getting to be a significant fraction of the cluster size. And could you scale it? Maybe. Would you ever want to, in a production environment, spend that much on just an InfluxDB cluster for this case? Almost certainly not. So.
Well, we're over time here, so I just want to do a little bit of a time check. I was reading through some of this stuff. You know, it looks like the Prometheus community is kind of in a little bit of a bind in terms of long-term storage. All the options have some real downsides, whether it be InfluxDB with, you know, you guys hit the scalability issues, but then there's also the closed source clustering issue that it looks like inside Prometheus is viewed as making Influx pretty much be a non-starter as the default option. They're looking at doing sort of generic writing backend so that you can sort of, you know, put anything in there. There's a lot of talk about long-term storage backends being write-only, so that you can't actually read and query. So it's up to you to use the query language of the database you're writing into to be able to do any aggregations. So that's a little unfortunate there also. So even if we did have a long-term storage system like InfluxDB or OpenTSDB, we still wouldn't be able to use the Prometheus front end to query that stuff. At least it looks like that's the case.
Joe, what's your gut reaction on if we started publishing JSON? Rounds? Do you think that has any value? Or
here's what I think might be interesting. If we have a way to export data out of Prometheus, right? So because we're in a situation where the Prometheus storage backend is good enough for scalability runs. Okay, let's ignore sort of long-term storage for clusters in general. So it's good enough for scalability runs. We're not going to be collecting so much data that we have to get it off host directly. And so now it's a matter of, okay, we have this data sitting around. How do we actually make use and share that? My ideal here would be to have a way to export that from Prometheus full fidelity, import it back into Prometheus if you want to for sort of live querying. And so this, you know, and it looks like there's talk of having an import API, and so this doesn't seem like, and all the exporting, there's an exporting PR for doing live export to an external long-term data storage, and that's hung up on questions of retries and reliability and keeping up and synchronous versus asynchronous versus buffering, that type of thing. If we say, you know what, this stuff is all offline, and it's all, and none of it's happening real time, it may be easier to actually move Prometheus in some of these directions if we want to try and move Prometheus. I mean, it's not like we have, engineers falling out of trees here. So, in that case, I mean, like exporting the JSON gets us there. Another interesting thing to think about is that, Prometheus is written in Go. Is it possible to extract the Prometheus sort of query language, query processor, and run that in a batch mode across JSON data, right? So now, I could imagine a command line tool where you point it at some sort of store on disk, and this thing just runs and churns through that, loads it from disk as necessary, and uses the same query language as Prometheus. So it's essentially offline, post hoc analysis. I
think you don't even need to go that far, because Prometheus has something called exporters, and they're normally used for things like applications which aren't instrumented for Prometheus, things like tailing log files.
Right.
That data in. So you could have an exporter, and they may already have one, which would just read the JSON and ingest it into Prometheus.
Okay, does that time work with like more historical data? Will it insert it into, or is it just, because a lot of these things, they're only built to ingest stuff that's happening, now. To some definition of now, right? And so if you use one of those exporters to give it data that came from last week, will it freak out? I don't know.
That's an open question for me.
Yeah. So I don't know. So it sounds like we're trying to use Prometheus in sort of a weird way. I think the JSON stuff, if we can get this stuff exported as JSON, then, that's at least, something that is well understood and can be widely used. But, if we're not careful, we're going to end up rewriting all the sort of, aggregation calculations on top of that JSON output, which seems silly, right? So if we can get the best of both worlds, where we get some sort of interchangeable format and we can actually use the Prometheus query language against it in some way, I think that, just I think it's about keeping the eye on the prize in terms of what the scenarios are, in terms of what we want out of them. The observation of both is not unreasonable, right? We do the JSON and the raw Prometheus database. That's not crazy.
Sure, it leaves our options open.
One thing that I did want to mention, and we are totally out of time. If Prometheus works like I think it might work, it might be possible to actually do a little bit of a binary search across a timescale to actually take a data set, take Prometheus, and say, at what times do we have interesting data for this metrics? And so the question there is essentially, you're hitting that 11,000 point. When you do that step, does that essentially downsample it? So if you say step equals 2, does that say I want to actually return every second step? Could you go up to step equals 100 and do a wider thing, find out where you might have hit a data point, and then zoom in into that? That might be a way to go also, in terms of like building, because it's like, again, it's like, Prometheus doesn't have the way to say, when is there interesting data for this time series? You have to essentially know the time you're looking for. So that, building some tuability around that might make this whole thing flow a heck of a lot better.
Yeah.
But very interesting stuff. Thanks for demoing.
Cool.
And with that, I think we are out of time. Thank you, everybody. And since we have this recorded, we'll try and post it and see how all that works. It's a brave new world for us. And see you later.
Good day.
Thanks all.